they might like you to think to do that, but you can't. It can be done. So if you want to copy something.
So you're open as can
Linux, Windows, and Mac. I kind of thought so, but I didn't want to claim that.
Yeah.
Thank you for looking that up for us. Incidentally, I forgot to say it earlier, but interrupt with questions anytime. This presentation is driven by the attendees. Any other questions or comments?
How big of a printer do you need to print that spool that you have there? What size of printer?
What size of printer do you need to print the spool? Not a very big one. This spool, I think when I developed it on the Lulzbot. And I had a Lulzbot Mini, and what size was that? 160 millimeters or something? Not very big. I think that spool is 5.5 inches or something like that. Been a while since I've looked at the numbers.
What's the vertical dimension?
Typically they're near cubical.
Okay.
Typically. The Prusa's and the Prusa is like 230 by 250 by, maybe it's a little taller, 250-ish. We bought a Voron, which I haven't quite finished yet, a Voron V2.4 to replace his artillery, which was 300 by 300 by 400, I think. That was a fairly big one. The artillery is another printer. It's one of these incredibly affordable, I think it was like $400 or something like that for a 300 by 300 by 400. We're talking a pretty big printer now. Now that is a bed slinger, which means the bed moves forward and back in Y. So X is this way, and then Y is forward and back, and Z is up. And so the bed slingers typically were the lowest cost printer style, but they require twice as much space depth-wise. And enclosing one is not incredibly practical because of, even if you do enclose it, you've got twice the volume, so it doesn't hold its thermally as well. And your parts are moving. So if you try and print something tall, you'd think it wouldn't work. It actually does work pretty well, but there's all that mass moving back and forth. And if it's a thin part, you can imagine it might wiggle around.
Do these all run on 120 volts, or are they 240?
Typically they'll run on either, but the real question, so you asked about voltage that they run on. The real question is how much power they consume, right? And 100 to 200 watts typically, once they're up to temperature. The really large ones, when they're coming up to temperature, they can consume a lot of power. I have one that's 360 by 360 by 360, and the bed is divided up into 16 separate areas so they can heat it up. Because if you ran all the bed heaters all at the same time, the 120 outlet wouldn't do it. I think that one's got 300 watt power supplies on it. It's also got 5 print heads, and each print head has a 60 watt heater in it, plus a motor. So they're smart about it. They stage it.
So the startup one is where, and how long does that startup process take?
Depends on the temperature that you're selecting. If you're going to go for ABS, you want the bed at 110 degrees C.
5-10 minutes.
Takes 10 minutes or so.
Explain that. Why do you have to have a heated bed?
Heated bed. I didn't talk about the heated bed. Thank you. So the early printers, the simplest and cheapest ones, didn't have heated beds, and about the only thing that you could print was PLA, because you want the product, the object that you're printing, to stick to the bed while you're printing it and come off when you're done. And that's not, the easiest thing to do. And so it turns out that by heating the bed and using the right kind of a material on the bed, they can get something that will stick while it's heated. And it also helps heat the chamber and the environment around the print to reduce the warping. And then when the bed cools, the part comes off. And I often just pull them off, before it's cold. But if you don't touch it, after a little while you hear crack as as it releases. And you go over there and it's just loose on the bed.
How long does it take to print that spool?
This spool here, about a 5-hour print. They're not fast. I'm not printing it fast. I'm much more interested in quality than speed, and PET-G does slow you down a little bit. It's not the fastest material to print.
Are they noisy? Are the printers noisy?
The noise level of the printers varies. Some can be fairly noisy. The fans are noisy, and the motors are stepper motors, and they make that whine depending on how they're operated. The printers that I have are not very noisy. They're in a bedroom that's across down the hall from the master bedroom. We really can't hear them from the master bedroom. But the 360 by 360 by 360 that's in the living room right now, sometimes I hear it all the way down the hall, because that one, there's more. It's got steel panels in it. It makes a little bit more noise.
Do they smell? Do they create a smell?
Do they smell? That depends on the plastic you're printing. And
ventilation.
do they need ventilation? Some materials you're printing really, you don't want to smell it. And some of them, like ABS, has kind of a nasty smell, and you really don't want to smell that.
Do they have exhaust on?
Some do. Some have exhausts and filters, and that's something that if you want, you can look for it when you're shopping for printers. Or you can add in an enclosure that has that if you don't have it. But PLA smells like French toast. It's very weak, and unless you stick your nose in the printer, you can't smell it. PLA is a plastic that's used a lot in the medical industry for things that they embed in people, so I tend to think that it's less, it's not petroleum product, it's actually made from plants. PET-G, you don't really smell much. ABS is pretty stinky. ASA is about the same, maybe a little bit less.
You really don't want to breathe the higher engineering.
No, you don't want to breathe it. The way I figure it is, if I can smell it, I don't want to stay there very long. But if you have an enclosed printer and you don't open the printer until it cools to room temperature, most of that stuff is plates out on the inside of the container. Filter right next to the printer. Yeah. Some people are really bothered by this stuff, and some people it doesn't bother them at all. So it's kind of a gasket material, yes.
TPU.
TPU, and there's some other materials as well. And it's on my list, but I didn't like my thumb, so I didn't get to refer that. So I've printed quite a bit of TPU. Now I haven't tried to print the really, really hyper flexible TPU, like Ninja Flex and stuff. It's really flexible, and it's really hard for the printer. So that if you think about how the print head is made, it's got a couple of gears that are pushing the filament down a tube, and at the other end of this tube is the heater and the hot end and the nozzle. So that pushes it down this tube and it melts and squirts out. And they're trying to control exactly how much filament they put out when. And if that filament is hyper flexible, it gets harder and harder. And the design of that print head needs to be right. If you put a really flexible filament into a machine that's not really designed for it, the filament comes out somewhere that you never expected filament to come out. But sag in the product? Surprisingly not. Surprisingly not. Now TPU is a very interesting material, and it's, the filament is real floppy, and you print something with it that's got some mass to it, and it's soft, but it's not flexible anymore. I mean, the three-dimensionality of it really changes the properties. But it's great for feet and gaskets and grommets, and it won't handle a tremendously high temperature. If you want to handle high temperature, I heard the other day, Prusa had a big announcement. They have a new print head for the XL. They're sort of semi-industrial machine with multiple heads. They can print silicone. And they print silicone by feeding 2 filaments into the print head. And the filaments are actually tubes, and the silicone components are in the tubes. And they mix it and squirt it out. So it's really a mixing system But you can print silicone, and I guess that's good to hundreds C. I don't know what their particular material ratings are. But if you have a need for that, somebody's making it. And that's a high-end consumer grade machine. That's not even an industrial machine.
So a number of plastics degrade in sunlight. Do you have certain filaments that you would prefer to use in the outdoors in
Sunlight.
Not?
PETG is pretty good. ASA is pretty good. I think PP is pretty good also. So absolutely a good question when you're shopping filaments. It's one of the things you want to consider. Yes, you're next.
So, file off of like Thingiverse or some of the other places you can file. Is there anything that you should look out for? Malware type situation with
Files and malware. I don't think you can have an STL file with malware because it's just triangles and coordinates. I would tend to not load G-code. I've never heard of anybody having a problem, but the G-code could tell your heater to go to 300C or something. Now, your printer should have protections in it, but sometimes the ones that come out of China, they've disabled the protections. So, you know, it maybe could go to a temperature that it shouldn't really go to. But your slicer will never do that because you've got settings in that. So now there's a kind of file that's come out called a 3MF file, and that's gaining popularity, and it is fairly widely used, and it's really a zip file that can contain anything, and so it could contain malware. Now, I haven't heard of anybody putting malware into 3MF files. And I don't know how we would get out of the 3MF file and do anything useful.
Just give it
But that's always a possibility, and that people are really clever about it. Hackers are really clever.
So is there a coating that you could spray on PLA to keep it from degrading? If you were, you know,
To keep plastics from degrading, paint. It just any UV, Krylon, anything to absorb the UV. I was just reading last night about. I asked ChatGPT, which is a pretty good resource on 3D printing, by the way, or any of the AIs should be. There's so much information out there, though you can only believe about 72% of it. So you have to. Somebody said you need to know the answer before you ask the question. I don't think it's quite that bad, but you need to be suspicious. Anyway, I asked it, I hear all the time that ABS is no good in the sun, and yet, helmets are ABS. I mean, there's all kinds of kids' toys that are ABS. How bad is it? And it said, it really depends on the color. Black ABS is pretty darn good because it's loaded with carbon. And, the sun affects the surface, but doesn't fall apart for a long time. So it depends. If you're going to make something for POTA soda, it's not going to see enough sun. But if you're going to put it on the roof, that's different.
You can't see his arm over here.
Yeah, you're out of my peripheral vision. It doesn't quite go that far. Thank you.
Have you ever heard of Onyx?
Onyx.
Here's some
No.
examples. This is Onyx now. This is high-end kind of 3D printing I learned in the Air Force. And it's in our in our trials of this stuff, we've exposed it to everything known to man, and the only thing that degrades it is battery acid over a long period of time. We were printing battery electric forklift battery cell caps, and they would last about 3 to 4 months, and then we'd have to put a new one in on there. That's the only thing that degrades this. It's high end. It's $167 a roll for Onyx, and it melts. The extruder temperature's 230 plus C to get it out the extruder. And
Too bad.
right,
Most printers will make that.
the printer we were using was Mark Forge, and they use their own slicing program called Waze, and it's phenomenal. Like I said, we've made all kinds of automotive parts using that, and it's durable, it's strong, and we're using Fusion 360 to design the parts with. But you can make all kinds of cool things. This was a hand design, learning hand-ear coordination for CW. So I designed that and put that together, but the Onyx is the best I've seen.
Great.
I actually have it in my camera.
There are a lot of engineering grade materials now. Be careful about carbon fiber because it's kind of nasty stuff, and when you print it, you end up typically with carbon fibers sticking out of the thing you're printing. So if you handle it, you may end up with them in your fingers. So I bought carbon fiber, but I haven't used it. But if you use it, you kind of need to maybe coat it afterwards or sand it or something, and you don't want to breathe that stuff. So be very careful. There's also glass fiber, which is bodies are a little bit better at taking care of glass fiber, and glass fiber comes in colors. Carbon fiber is pretty much always black. Was there another one over there?
If there's something I can't print, can I print it in PLA and decide, yeah, that works really good, and then send my STO file off to somebody that they're not?
Absolutely. So his question was, can you test it in PLA and then send it off to a lot of the commercial places that have printing? They can even CNC it out of aluminum. You know, it's a good way to decide whether your design fits, and then you can have it manufactured in stainless steel, you know, whatever. There's a lot of choices.
You can design and print a part and then send that plastic part to a foundry, and they'll use it as a mold to cast a part out of aluminum or metal or something.
So what printers, what do you need to print in multiple colors? What
do you need to print in multiple colors? So there's fundamentally two systems for printing in multiple colors. One's to have multiple print heads. There are some printers that have two heads together. There are some printers that have two heads that kind of one at a time come out and print. And then there are the printers where it picks up the heads. So it's got a shuttle that can grab any head. That's what the Prusa XL is that I have. And then there's a whole bunch of printers that use either built-in or externally added filament systems, and they're essentially unloading and loading the new filament in the one print head. That's what the Bamboos do. Though they have a new system which doesn't change print heads, but it's crazy. It changes nozzles and stuff, and then rethreads the print head. So now there are limitations. The multiple head is in many respects the best deal, but it's more expensive and more complicated because you can print different materials. For example, you could print TPU feet on something that was some other ABS or something. And typically, rethreading the same print head with different materials, it's very difficult to get it to purge completely different materials out of the print head. Especially some materials aren't very compatible. For example, PETG and PLA don't really like to attach to each other. So some people use one for supports when they're printing something out of the other. Supports isn't something I've mentioned, but it's probably worth mentioning. So when you print something, you can't print horizontally in space because there's no support. You're going to squirt hot plastic into midair. It's going to fall. So sometimes you can angle the part 45 degrees because you can print 45 degrees. And you can print a little steeper than that, but at some point you can't. So you do support. So you print material there that you break away. And that supports can be automatically generated, or you can manually design them. And the thing is that supports, you have to break them off, and it can be very hard, and they tend to leave surface imperfections. But if you're printing PETG and you use supports made out of PLA, they don't like each other, so they don't really stick. So you end up with a kind of a nice situation, but you kind of have to have a multi-head printer. So obviously the cheapest thing is a rethreading system that just reloads the head. But it's also the slowest, and it wastes the most filament because each time it rethreads, it has to purge the head, and on the bamboo, for some reason they call it poop, and it comes out, and they end up with big piles of these little spongy balls of filament as it's trying to flush out the head each time it changes. Now, if you do something like this, most of my designs, and in fact this badge is 3D printed, I change colors once. You can do it manually. You don't need a multi-fancy printer. But if you print something that's really color, there may be hundreds to thousands of changes. The waste can be way more than the object that you're printing. Of course, if you print 5 of those, the waste is the same. So you can kind of scale it
Okay, you're saying print 5 on the same.
at the same time. Yeah, they have to fit physically, but you can. That's one thing about these printers. Once you get a design you like these little spacers, I can say fill the print bed with those spacers, and print 50 of them. You know, if you get clever, you can even beat the slicer because you can pack them tighter than it can figure out.
For home use, you're talking additive 3D printing, where it's
Yes.
just squirting plastic out of the nozzle like a hot glue gun in layers. There's all kinds of different printing.
There are many other kinds we didn't talk about today.
Right, resin, where the print bed just sinks into a vat of resin, and the top layer is hit with a high intensity laser, and it cures the resin. All kinds of stuff like that.
I borrowed that for
But, yeah.
15 seconds. So is there anybody here that has not registered for Quartzfest yet? Then you don't care.
Yeah, resin is messy.
Yeah, resin is a chemistry experiment, and you end up with hazardous materials and lots of alcohol. And I've chosen not to get into that. But there's a lot of interesting ways to do 3D printing. And the resin is interesting because it's much finer, much more precise. So if you want to print these little action figures and all that kind of stuff, you'll have to paint them. So you better have good eyesight and a sharp paintbrush.
Resin printers are really popular with the tabletop miniature players, D&D and that sort of stuff.
So we have about 2 minutes left. Do people want to come up and look at this stuff? And you can ask more questions when you're up here, and we'll finish it up. Thank you.
I'm gonna do something that I failed to do the other day.